In section 2.2, we're going to be talking about quadratic functions. And the general form of a quadratic function is this: f of x equals ax squared plus bx plus c. Okay, when we're looking over here, let's give a rough sketch. Okay, that's just of a basic parabola. So let's just talk about the different terms. This is called the what? The origin, or more precisely, vertex. Good. So this is called the vertex, and in this particular case, this vertex is at approximately 0, 0. Okay. This is called your axis of symmetry. Meaning if you were to fold it like a piece of paper in half right there, our graphs should be right on top of one another. So it has y-axis symmetry on this. And this one is considered a min. And if you want to think about it, it's like a valley. So it's a minimum value. Okay, the other thing, let's see. Also in this particular format, this a term, which is the first term, a is greater than 0. So if this is positive, if a is positive, then we know that this parabola opens up. And what we mean by opens up is right here. It opens up. Okay, let's see one over here, roughly. Pretend that was a somewhat symmetric. Actually, let me just draw a better graph. Okay, let's talk about this. This, if it's hard to see right there because the numbers are kind of squished, but this is going to be our vertex. And what does it look like? It's approximately 0, 5. Okay, the vertex is 0, 5. The axis of symmetry, is x equals 0. Specifically, more precisely, it's usually it's the equation x equals whatever this x value of your vertex is. So even over here, we said axis of symmetry, but we didn't specifically give the equation for it. X equals 0. A is less than 0. That means when this value is negative, that's what less than 0 means, then our graph opens down. And if this quadratic is a minimum, what is this one going to be? A max. And we can think about them, like I said, mountains and valleys, and if that helps. So this is a max. Alright, you want to know the vertex, the axis of symmetry, and understand min and max. Alright, the next thing we're going to do is we're going to graph our parent graph right here, the function f of x equals x squared, and then we want to do g of x on this one. So I'm going to pause it for a second and let you remember your transformations to see if you could give me a sketch of this thing. So to graph this, we can either make a table of x, y values, so plug in some values for x, solve for y, and then plot them, or we can recall our transformation rules. So if it's inside parentheses and that's -4, what's that tell us to do? Shift to the right 4 units. And what about +1? Up 1. So if I take this vertex, which was 0, 0 here, and I shift it to the right 4, up 1, that puts me about here. And I'm just doing a rough sketch. If I needed it to be exact, I would pick values for x and solve for y. And plug them in. Let's just do that. Let me pick a few of them. So um, let's let x equal 2, and let's do x equals 6. What happens when x equals 2? So 2 minus 4 is negative 2 squared. 4 plus 1 is 5. So it should be 2, 5, which actually not too bad for a rough sketch. And then what would 6 give us? 6 minus 4 is 2. 2 squared is 4. Plus 1 is 5. 6. Somewhere right there. So it's pretty close. Pretty good sketch right there. Anyway, you can find exact values by using that procedure if you need to. The next thing we're going to look at standard form of a quadratic equation. So you get your f of x is equal to a x minus h squared plus k, where a cannot equal 0. The vertex in particular is going to be your hk, and the axis of symmetry is always x equals whatever the x value of the vertex is. So that's going to be x equals h by definition. Okay, and we did a little bit of this with circles when we went from one form of a circle to the other, and we had a standard form where it was really easy to be able to give the center and the radius, and then we did the one that was not so easy to tell, and we had to use the complete the square to put it into the format that was most suitable for that. Okay, so we're gonna, given the quadratic function, so f of x is equal to negative 2x minus 3 squared plus 8. This is in standard form, and in standard form we can determine a lot of different things. All these characteristics we're going to look at eventually. So tell me what the first thing 2a says. Determine whether the parabola opens up or down. So we go directly to the a value, and it's negative. So what do you think? Opens down. All we care about is the sign. If it's positive, it opens up. If it's negative, it opens down. The next thing is find the vertex. Well, they told us the vertex is HK, so it's going to be opposite of this. So we get the vertex is going to be 3, 8. Okay, because this formula is minus h. So the vertex is 3, 8. How do you find x-intercepts? To find the x-intercepts, you let y equal 0. So basically, if we're going to take our function, our f of x is equal to y, so we let that equal 0. To find your x-intercept, you let y equal 0, and so our function, this is y. Remember, it means the same thing as y, so we let y equal 0. So that's what we did here. I just put the 0 on the other side. Solving this, so let's subtract 8 from both sides. Divide both sides by negative 2. And we get x minus 3 squared is equal to positive 4. How do you undo a square? We take the square root of both sides. So you get, when you take the square root of a square, you just get what's left inside. And then you get plus or minus 2 over here. Don't forget, when you take the square root, you get plus or minus. So now if I was to break this apart, actually I'll move 3 to the other side. So add 3, that gives me 3 plus or minus 2. Now let's give our two solutions. 3 plus 2 gives us 5, and 3 minus 2 gives us 1. So that's going to be our x-intercepts. Now the x-intercepts is going to be where our graph crosses the x-axis. We're going to go back and put all this stuff together and graph our function at the very end. Okay, we said if we find the x-intercepts by letting the y equal 0, when we find the y-intercept, we're going to let the x equal 0 and solve.